According to the California Electrical Code, CEC, detached structures such as guest houses must have their own grounding electrode system. This means that the subpanel within the guest house should be grounded separately from the main electrical panel of the existing house. The electrician may have believed that since the subpanel is connected to the existing house through a 4-3 Romex, which includes a ground wire, the subpanel is already grounded. However, this is not sufficient to meet CEC grounding requirements for detached structures. The building inspector is correct in stating that the new guest house subpanel must be grounded to the new ground wire that was installed in the foundation. This is because, firstly, the ground wire in the Romex only serves as a bonding conductor between the subpanel and the equipment it feeds. Secondly, the Romex does not provide a reliable path to ground for the subpanel and equipment in the guest house. Thirdly, a separate grounding electrode system is required to ensure proper grounding in the event of a fault or surge. CEC Section 250.32(3) requires that detached buildings that are required to have a service shall have a grounding electrode system. To comply with CEC requirements, the grounding wire in the new foundation should be connected to the subpanel in the guest house. This will provide a proper grounding electrode system for the guest house. When you meet with the inspector's supervisor, present the following points. Firstly, explain that CEC Section 250.32(3) requires separate grounding electrode systems for detached structures. Secondly, cite the electrician's misunderstanding that the ground wire in the Romex provided sufficient grounding. Thirdly, state that the guest house subpanel has been connected to the new ground wire in the foundation as per code requirements. Fourthly, express your understanding of the importance of proper grounding for safety and code compliance. Grounding is essential for electrical safety. It provides a path for fault current to return to the source, tripping a breaker or fuse and preventing electrical shock. In the context of a detached guest house, relying solely on the ground wire within the Romex cable that runs back to the main house is insufficient for a few reasons. Firstly, the ground wire in the Romex is primarily intended for bonding, which means connecting metallic parts of the electrical system together to ensure they are at the same voltage potential. This helps to minimize the risk of electrical shock if someone touches two different metal parts at the same time. Secondly, the ground wire in the Romex may not be sized appropriately to handle a large fault current. The size of the ground wire is typically smaller than the ungrounded conductors, and it may not be able to safely carry the amount of current that would flow during a ground fault. Thirdly, a path back to the main house through the Romex ground wire may not be reliable. There could be loose connections, corrosion, or other issues that could impede the flow of fault current. A separate grounding electrode system, on the other hand, provides a dedicated and reliable path to ground for the guest house. This system typically consists of a ground rod or ground ring that is buried in the earth and connected to the subpanel. The grounding electrode system provides a low impedance path for fault current to flow back to the source, ensuring that the breaker or fuse trips quickly and safely. CEC Section 250.32(3) specifically addresses the grounding requirements for detached buildings. This section requires that detached buildings that are supplied by a feeder or branch circuit and that contain a separately derived system or that utilize equipment grounding conductors for grounding equipment shall have a grounding electrode system connected to the building disconnecting means. The grounding electrode system must comply with the requirements of CEC Section 250.50, which specifies the types of grounding electrodes that are permitted and the methods for installing them. Some common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The choice of grounding electrode will depend on the soil conditions and the availability of suitable grounding electrodes. In addition to the grounding electrode system, the guest house subpanel must also be bonded to the grounding electrode system. This is typically accomplished by connecting a bonding jumper from the subpanel grounding bus to the grounding electrode. The bonding jumper must be sized appropriately to handle the available fault current. The importance of proper grounding cannot be overstated. A properly grounded electrical system is essential for protecting people from electrical shock and for preventing damage to electrical equipment. By complying with the requirements of CEC Section 250.32(3) and installing a separate grounding electrode system for the detached guest house, you can ensure that the electrical system is safe and reliable. When meeting with the inspector's supervisor, it is important to be prepared to explain the code requirements and the reasons for them. By demonstrating a clear understanding of the code and the importance of proper grounding, you can help to resolve any concerns and ensure that the electrical installation is approved. Remember to emphasize the following points. Firstly, the ground wire in the Romex is primarily intended for bonding and may not be sized appropriately to handle a large fault current. Secondly, the path back to the main house through the Romex ground wire may not be reliable. Thirdly, CEC Section 250.32(3) requires that detached buildings that are supplied by a feeder or branch circuit shall have a grounding electrode system connected to the building disconnecting means. Fourthly, the grounding electrode system provides a dedicated and reliable path to ground for the guest house. By addressing these points and presenting a clear and concise explanation of the code requirements, you can help to ensure that the electrical installation is approved and that the guest house is safe for occupancy. It is also worth noting that the specific requirements for grounding electrode systems can vary depending on the local jurisdiction. It is always a good idea to consult with a qualified electrical inspector or engineer to ensure that the electrical installation complies with all applicable codes and regulations. Furthermore, consider the practical aspects of the installation. For example, ensure that the grounding electrode is installed in a location that is accessible for inspection and maintenance. Also, be sure to protect the grounding electrode and bonding jumper from physical damage. Proper installation and maintenance of the grounding electrode system are essential for ensuring its long-term effectiveness. Finally, document all aspects of the grounding system installation, including the type of grounding electrode used, its location, and the size of the bonding jumper. This documentation will be helpful for future inspections and maintenance. In summary, grounding detached guest houses requires a separate grounding electrode system in accordance with CEC Section 250.32(3). This system provides a reliable path to ground for fault current, ensuring electrical safety. Understanding the code requirements and properly installing the grounding system are essential for compliance and for protecting people from electrical shock. It is important to emphasize that the ground wire in the Romex cable is not sufficient for grounding the subpanel in the detached guest house. While the ground wire in the Romex serves an important function for bonding, it does not provide the same level of protection as a dedicated grounding electrode system. The grounding electrode system provides a low impedance path for fault current to flow back to the source, which is essential for tripping a breaker or fuse quickly and safely. This helps to prevent electrical shock and minimize the risk of damage to electrical equipment. When discussing this with the inspector's supervisor, it is important to be respectful and professional. Explain that you understand the importance of proper grounding and that you are committed to complying with the code requirements. Also, be prepared to answer any questions that the supervisor may have about the electrical installation. By demonstrating a willingness to learn and a commitment to safety, you can help to build a positive relationship with the inspector's supervisor and ensure that the electrical installation is approved. Another important consideration is the size of the conductors used for the grounding electrode system. The grounding electrode conductor must be sized in accordance with CEC Table 250.66. which specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Similarly, the bonding jumper must be sized in accordance with CEC Table 250.102, Seat 1, which specifies the minimum size of the bonding jumper based on the size of the largest ungrounded conductor. Using the correct size conductors is essential for ensuring that the grounding system can effectively carry fault current and provide adequate protection against electrical shock. In addition to the size of the conductors, it is also important to ensure that they are properly installed. The grounding electrode conductor must be connected to the grounding electrode in a manner that ensures a permanent and reliable connection. Similarly, the bonding jumper must be connected to the sub-or grounding bus and the grounding electrode in a manner that ensures a permanent and reliable connection. Improperly installed conductors can compromise the effectiveness of the grounding system and increase the risk of electrical shock. It is also important to consider the location of the grounding electrode. The grounding electrode should be located as close as practicable to the subpanel in the guest house. This will help to minimize the length of the grounding electrode's conductor and reduce the impedance of the grounding path. The grounding electrode should also be located in an area where it is unlikely to be disturbed or damaged. For example, it should not be located in an area where it is likely to be driven over by vehicles or where it is subject to excessive moisture. Choosing a suitable location for the grounding electrode is essential for ensuring its long-term effectiveness. Furthermore, it is essential to coordinate with other trades during the construction process. For example, the electrician should coordinate with the plumber to ensure that the grounding electrode is not located near any underground water pipes. Similarly, the electrician should coordinate with the concrete contractor to ensure that the grounding electrode is properly embedded in the foundation. Effective coordination between trades is essential for ensuring that the grounding system is installed correctly and that it complies with all applicable codes and regulations. Remember to document all aspects of the grounding system installation, including the type of grounding electrode used, its location, the size of the grounding electrode conductor, and the size of the bonding jumper. This documentation will be helpful for future inspections and maintenance. It is also a good idea to take photographs of the grounding system installation before it is covered up. These photographs can be helpful for troubleshooting any problems that may arise in the future. Maintaining accurate and complete documentation is essential for ensuring the long-term reliability of the electrical system. When explaining the code requirements to the inspector's supervisor, it is helpful to use diagrams and illustrations. Visual aids can help to clarify complex concepts and make it easier for the supervisor to understand the grounding system installation. For example, you could use a diagram to show the relationship between the subpanel, the grounding electrode, the grounding electrode conductor, and the bonding jumper. You could also use illustrations to show the proper methods for installing the grounding electrode and connecting the conductors. Using visual aids can help to make your presentation more effective and persuasive. Also, be prepared to discuss any alternative grounding methods that may be permitted by the code. For example, the code may allow the use of a metal underground water pipe as a grounding electrode, provided that certain conditions are met. If you have used an alternative grounding method, be prepared to explain why you chose that method and how it complies with the code. Being familiar with the alternative grounding methods can help you to address any concerns that the inspector's supervisor may have. Furthermore, consider the impact of any future changes to the electrical system. For example, if the guest house is later expanded or renovated, the grounding system may need to be upgraded to accommodate the increased electrical load. It is important to plan for future changes to the electrical system and to ensure that the grounding system is capable of handling the anticipated load. Planning for future changes can help to prevent problems down the road and ensure the long-term reliability of the electrical system. In conclusion, grounding detached guest houses requires a thorough understanding of the code requirements and careful attention to detail. By complying with the requirements of CEC Section 250.32(3) and properly installing the grounding system, you can ensure that the electrical system is safe and reliable and that the guest house is protected from electrical shock. Remember to communicate effectively with the inspector's supervisor and to be prepared to answer any questions that they may have about the electrical installation. By working together, you can ensure that the electrical system is installed correctly and that it complies with all applicable codes and regulations. And always consult with a qualified electrical inspector or engineer if you have any questions or concerns.